First things first, thank you for the opportunity to be speaking here. It's very nice. And I will about a radically simple way to scale your dApps. And what that means is a way for you to create dApps that are faster, that are stronger, that are smarter, and you can go beyond the capabilities of the trading that is being done right there. You can do amazing solutions that we're gonna cover later. But right, what's the Doom case? Well, someone another day posted on Twitter, this was roughly a year ago or more. Well, if Ethereum is really the world computer, can someone explain how no one else managed to get Doom running on it? And we have this guy he did manage to cross-compile Doom to RISC-V and run it on WASM, so you can actually play it. For us to do that, right? For this, you need a stack that needs more thinking than just the traditional EVM. So that's why we have to do some cover of what are modular blockchains and how do they work. Okay, they have store the data that's going to be used by your applications. Then we have the consensus layer responsible for ordering the transactions that arrive. Then we have my favorite one, of course I'm biased here, but is the execution layer. And the settlement layer where everyone agrees, or even an out VM, right? The execution layer is a very simple state machine that, given a state and receives an input, always produces a new state. This is very simple, right? The problem is on Ethereum, on blockchains, whenever we do that, we name exact state. It can't just be a new one. It has to be that specific one. So this is essentially what forms an execution. So what's the kind of dApps that you're building? Are you doing a DeFi solution? Are you building a game? Are you building something that needs intensive computation, or you just want to run some trading? Do you prefer writing your apps on Solidity, JavaScript, or Python, or all of them together? Do you need any specific resources? Do you need some specific compilers? Is introspecting low latency is always good, but do you need low latency outside of it? So there's an infinite list for you to pick. And for us, the ideal solution for the kind of solution that we wanted to solve was adding Ethereum, RISC-V, and Linux to generate what is our execution layer, okay? So what does this bring? What are the advantages that this whole mix of Ethereum, RISC-V, and Linux brings? Of course, you get all the benefits of the base layer with the security of Ethereum. But then with RISC-V and Linux, you get a more performant computer because data before can now be used and run on the chain. And this is kind of shows the comparison of what EVM tooling is with Solidity. I know OpenZeppelin is amazing, it's easy to manage packages, but I like to compare it as a plier. It's my favorite tool, it's very good. You can do many things with it, you can bend things with it, you can pull things with it, cut, you can even hammer and nail. What are these kinds of tools? What are tools that I'm talking about? You can use OpenCV, you can use scikit-learn, you can use Redis, SQLite, and you can use any language that you want and you're familiar, and it's packages and package managers. You can use Python, you can use C++, you can use Go. Go is always trying to run from me, I don't know why. He doesn't like the company of Python and C++, I guess. But thank you, Rust is here, okay? Just stay. But anyway, how does this happen? How is it possible for us to have an execution layer that takes all of this and has the computation capacity without creating a major bottleneck on the base chain, right? Well, we're not replacing the EVM, we're delegating its execution somewhere else. So what we do is we send a transaction to the base layer, and this transaction is constantly observed by the Cartesi machine nodes, okay? So these nodes read those transactions as input, the blockchain, sorry, not send the input back, but they're basically settling there. And if you need to read the state fast, you can just easily access the node to read its state. You can start to think of it as a very, very minimalistic version of how the framework behaves. And of course, if you have multiple nodes running instead of just one Cartesi machine, you will have multiple Cartesi nodes, and all of these nodes will be communicating, executing the inputs for that specific dApp, and verifying each other to settle. And this can be expanded, right? So imagine that you need, I talked about modularity in the beginning of the presentation. So imagine that you need a stronger data availability layer. So you can use Avail for that, for example. You send a transaction to Avail or any other data availability layer. One machine processes everything and then settles on the base layer, but with that commitment that was made for Avail in mind. This way, you can actually process things and process a larger chunk of data in your applications. So just to look back at what we said, there are two parts that are very important to this solution, right? The first one is the app-specific rollups that give your app a full CPU, because then you're not computing for block space, because you're delegating the processing to somewhere else. You don't even have to pay gas for this processing, just for the data that's being sent. And the second part is the expressive general purpose execution environment. This means you have an execution environment that's capable of running more, that has more access to more resources. You get a rootfs system, you got all the libraries and all the packages that you ever used. So just to have a good insight of what you can unlock with it, on these layers, you unlock so many more possibilities. So if we're just using the Ethereum layer 1, we are kind of bound to token sales and gentrified DeFi. But once we start scaling the computational capacity, we can start doing some GameFi, or even some decentralized AI, even world simulators and a full complex metaverse. So just so you know, I like to highlight both of these architectures because we have two tracks going on. The first one is just building an app with Cartesi rollups, which is giving for a total of 5,000 in bounties. And the second one, which is a dApp showcasing the Avail integration, which is this case of using a DA together with our execution layer, which is pretty nice and it really unlocks lots of possibilities. So for you to have more inspiration and more idea on things that can build with Cartesi, I'm going to hand over to Shaheen, where he will do some showcase of the dApps and show you how to build one.
Hey, thank you, Joao. Okay, guys, so you just heard a little bit about what Cartesi is, how things are on a high level, like on a conceptual level. Let's just see some inspirational ideas that we have. So your bubbles are Ethereum blocks, actually. The amount of Ethereum you put on this bubble is the size of the bubble, actually. It gets larger the more Ethereum you put on it. And the momentum is conserved here. So you have to strategically think like where you want to push your bubble. You can consume the smaller ones, and you can get consumed by the larger ones. So it's a strategic game. Looks simple, but very interesting to play. Then we have something called Cryptopolis. I'm not sure if you have heard the, so here right now what we are doing is we have ported the whole economy of this game inside Cartesi machine. So you can inject ERC20 tokens and use them to have this economy built around this city. Again, another interesting game. And then we have some social applications. Here are two applications, Comet and Drawing Canvas. Both of these applications allow you to collaborate and generate art. Comet allows you to generate text-based art, and Drawing Canvas allows you to generate drawings on a collaborative canvas. And everything happening here is fully verifiable in this inside Cartesi, and you can verify the whole your brush strokes and everything inside Cartesi. So at the end of the day, you can mint a fully verifiable canvas. Then if you are an AI or machine learning enthusiast, we have a lot of like proof of concepts around that, some applications using that. There's this biometrics classifier for you to detect some spoof, some copies of these fingerprints and all. You can check out this particular example where you can have this model running inside Cartesi coupled with OpenCV. Now OpenCV is something very huge library, pretty much used in every image recognition out there. And then we have Lilium, which actually is a marketplace of carbon credits. So if you want to build something around green 5 projects, you could also think around that. And then for all other applications, you can scan this QR code to have a whole list of applications that were being built with Cartesi. Okay, for the time's sake, I'll be a little quick because I also have to show like how you can build applications. So if you can quickly scan this. Cool. And then we have Udemy course, which is like a masterclass of around 2 hours, which goes through like from the scratch to building an application. Also, how you can handle assets inside the app chains of Cartesi. That's gonna be is there. So somebody would be there if we are not here to answer your queries. Okay, let me just switch it to CLI a bit. Okay, guys, just a sec. So you have this Cartesi CLI that you use for bootstrapping your applications, creating an application. So let me just run this simple command, simple JS. You write the name of your application, and then you spec whatever language you want to pick. We have Python, Rust, C, C++. So it just creates a project directory for you. This is our project directory, simple JS. And if you look into this direct Docker container, that's where your code is gonna run. So you need Docker file for that. And your actual code, your entry point is within this src folder. So you have this index.js file if you try to inspect. So this is the entry point of the payload that you're gonna be getting for your application, right? You get it in a JSON format. It's gonna be a hex encoded, which you're gonna change it to JSON, and then you're gonna do all the functions that you need. So right now it's just logging that particular payload. We're gonna see how you can run and see those inputs. So this is a new example. You have to build it. Right now it's gonna take a little bit of time. I have this already built example. Let me just show you. Once you build this, like you have to do Cartesi build command. And this folder that you're seeing .cartesi is the build binaries that you need. So right now we're gonna be skipping the build because we already have it built. We just run. It turns up the validator. Actually, it turns up the whole node. So it's not just your backend, but the whole node, which has other components as well, which is gonna have some servers, which gonna be very handy for you to, let's say, inspect the machine for you. Here are the components of this particular node. And to send the inputs, what you can do is there's this Cartesi send command, which you can use, pretty handy command if you are testing backend applications, Foundry, everything default. This is kind of like the application address that is default when you deploy it on the local devnet. And let me just do a simple hello world here. And this is actually the log that we just saw in the index.js file. Also, let me just quickly show you the Explorer. If you have any questions till then, keep them ready. And yeah, I hope I can. Okay, it is here. So as you see, the input that we just sent is here. And if I click on it, if we check the data, that's like the raw hex and inputs, notices, reports, and vouchers as per your application logic. So this is like the gist of how your builder journey is gonna be. Thank you so much.